Good afternoon. This is Zach Zaharowitz of the Lighting Quotient, head of the applications group, and I'm joined by Paul Ford, our VP of product design. And today we will be unveiling the new elliptipar style S43X ensconce series of high-lumen uplights. And we're 1 minute into it and I already lost my voice. As we get started, two things I wanted to point out. We're obviously visible in a little window on your screen. You can feel free to move that around or totally close it. However, at the end of the slide presentation, we are going to stop sharing the PowerPoint and come on full screen so that Paul can show you a close-up view of some of the components. Also, Zoom has a Q&A and a chat function. We won't be making use of the chat during the presentation. However, feel free to use the Q&A, and if you think of a question during the slideshow, please use the Q&A, type that in at the end of the presentation. We'll try and pull up those questions and answer them. So with that, I'm going to turn things over to Paul.
Thanks, Zach. Zach said, my name is Paul Ford. I'm the VP of Product Design here at the Lighting Quotient. Thank you for joining us today in this webinar. Today, it's my pleasure to announce the introduction of our new S43X series, a high-output LED uplight. Before I get into that, I just want to quickly go through some of our ever-expanding LED product lines. Started out with smaller wall wash packages and have, as well as cove lights, and have moved into larger and larger packages, such as the 104 and the 136. These products have received industry recognition over the years, whether it be the PIA Award or the Next Generation competition. So it has been an ever-growing expansion of our product line for LED, as well as some nice industry recognition. So the new S43X comes in 4 styles. We have the 431, which is the smallest unit, the 432, which is kind of our double wide, 433, and 434. We're looking at kind of a view from above to the side, looking down into the unit, looking from below the S431, 432, 433, and 434. All of these are shown with the visor, the VO option. It provides about a 5-degree sightline cutoff. We also offer a flared visor, which is the F0 option, and that provides a horizontal cutoff to the light engines. We also do offer it without a visor if the application permits, sightlines permit, to use it without the visor. The 431 is 9 inches wide, uses 108 LEDs, and driven at 500 milliamp to produce about 14,800 delivered lumens at 170 watts input, which is about 87 lumens per watt. The 432 is 17 inches wide. It has 216 LEDs, produces about 28,700 delivered lumens at 340 watts. The 433 is 25 inches wide, 324 LEDs, produces up to 41,500 delivered lumens at about 500 watts input. And the largest unit is the 434. It's 33 inches wide with 432 LEDs, producing up to 53,400 delivered lumens at about 670 watts input. All of the units so far that you've seen have been wall mounted for uplight, but we also do offer a 1-way and a 2-way pendant that is compatible with any of the size fixtures. So if we take a look at the sell sheet, which is available on the website now, it gives you, the front page just kind of gives you some sense of scale and shows a image of all 4 sizes. On the back, you have features, benefits, application photo of a pool. We also have a cutaway section, which gives you some more detail of what is kind of under the hood. And up in the top right, we have a chart which compares all the different packages, the light output, as well as what the closest metal halide equivalent would be. And also we have an overlay of the 4 candle power curves. What is new and exciting about the product, not only the new light package being higher light output, but the chips that we're using are the latest LED chip architecture known as chip scale package The traditional package we have been using is a thin film flip chip technology, which had some benefits over the previous generation. This new generation is much smaller. There's less material. There's better thermal transfer to the heatsink, and it's much smaller in size, so the cost is going down. So this is really approaching the cost of a mid-power LED, but you can still drive them like a high power. Another benefit to this chip is the amount of light output is not diminished quite as much when you drive it harder, which is shown on the chart on the right. Typical flip chip will diminish in light output as you ramp up the current density. It will increase, but not at a linear rate, and that's what's known as droop. This chip will experience much less droop, so you can drive it harder and still get more light output. One of the biggest benefits that we are drawn to with this chip is the color over angle, and that refers to the color temperature or the color coordinates of the light coming out at different angles. So looking at the chart, at 0 degrees, you'll be looking straight down at the chip, and then as you go off to different angles, you're looking at it from all the way to 90 degrees in either direction. Now the red line shows a typical high power LED, and you can see even just going off to about 60 degrees, you have quite a departure from the original color as compared to the flip chip white, which is the chip scale package. It was very consistent over angle. The other thing that is unique about this chip is that it emits light from 5 sides. Rather than just the top emitting light, all 4 sides are emitting light. This created a challenge for designing the optics. So we came up with a new optic design, which still works around a single optical center, but it wraps completely around the LED so we can make use of all the light, including the light coming off the sides. This is a new optic, and we do have US and foreign patents pending. This is just a quick ray trace that we're looking at. This is actually the photo of the real extruded polycarbonate material. And this is a overlay of the Photopia study when we were designing it. This is the projected output of the LED. Now, when we use them all together, in the case of the 430, we're using 6 of these optics in a row, kind of like stadium seating, so they can see over each other. It produces a nice asymmetric throw, very elliptipar-like, have very, very sharp peak candle power, which runs back quickly to 0, so there's very little wasted light downward or trapped by the visor. This is a quick view of the light engine. You can see the chips are different than what you probably have seen in the past. They're very small. In this case, we're using 18 of the flip chip whites in series on a 6-inch board. The light engine itself is an extruded aluminum material. It's bright anodized, which helps with the emissivity to release heat away from the LED, as well as reflect light that might otherwise go in the wrong direction, and it reflects it back out of the fixture. Now, taking a closer look under the hood, it's a modular design. We're using a heavy extruded aluminum body to promote convection to cool the LEDs. And it's miter cut in the front, which we'll show you towards the end when we hold up the sample. The light engines are placed and mounted directly to the heatsink, and then the optics are placed over each individual light engine. This is showing all 4 of them in a 434. And when we were designing it, we designed this in SolidWorks is one of the programs that we use, but it also has a add-on feature for FlowWorks, which is thermal studies. And this is one of the studies that we were looking at when we were designing it. And you'll notice that the highest temperature that we're seeing is around 79, 80 degrees. When we actually built the fixture and measured the temperatures, it was spot on right at 79, 80 degrees. So it was good to see that the design efforts that we put in the beginning paid off in the actual design itself. The other feature that we have, we do call this an ensconce line, and it is similar to the old ensconce where you'd have a shroud mounted to the wall and the optics inside were aimable. So you could aim it forward for shorter setbacks or longer throw. This unit does have optics that aim forward and back, and it's locked in place with spring-loaded latches on either end, so we can lock it in place, but it's easy to adjust. As far as the catalog pages, we have catalog pages for each style. We're looking at the S431. Just as you would expect, you see the line drawings with dimensions, callouts. There's an image as well as a thumbnail of the ray trace. And what you see here is the thumbnail of the candle power curves. And the reason we show two is one of them is for 4,000 Kelvin 70 CRI, and the other is 2,700 Kelvin 80 CRI. So they're running at the same, consuming the same power, but as you can see, like most LEDs, the cooler the color and the lower the CRI, you have a benefit in total light output. On the back of the page, you have all the specification information for the style, the mounting, finish, etc. For each one. We'll dive a little deeper in a second. So this is the 431. 432 is the double wide. 433 has 3 light engines wide, and finally the 434 is the 4 wide. So if we take a closer look at the back of the page, the lumen wattage options are shown here. This is for the 431, so there's 108 LEDs driven at 500 milliamp, which is where this 5108 code comes from. Operates around 170 watts. And the lumens that we're providing are for 4,000 K 80 CRI, but that's just one version of it. If you click on where it says click here for scale performance table, it'll pop up a table, and this is organized by in 3 groups. The first group has no visor and no cover lens. The second group is the VO visor option, and the third group is VP for a visor in a pool. So the pool option or natatorium option comes with a fully gasketed lens. All the cord exits are sealed that run to and from the driver box to the head assembly. You'll notice it does say the VO option. You might be asking where is the F0 option for the flared visor. What we found is that the performance was nearly identical between the flared visor and the straight visor. Because of the straight visor is a little shorter and the flared visor allows more light out, it ended up being about the same performance. Mounting, we have W, S, and T are all wall-mounted units. W is for over a recessed outlet box in the wall. The S mount allows you to run surface conduit in and out through the side, and T is for the top surface conduit entry. We also have the 1-way and the 2-way to be ordered with the pendants get ordered separately. Finishes, we're offering the semi-gloss white now, but we can also offer any of our standard semi-gloss black or silver. We also can do any of the REL finishes or even a computer matched finish. Voltage and driver is the 8 voltage is a 120 through 277 non-dimming, 3 is for 347 non-dimming, and we also have M for 120 through 277 with dimming and K for 347 with dimming. Now you notice there's a link to this MA1303 that will open up a list of all the drivers that we use, and even on that you can open up another link directly to the catalog page for the driver itself. So in this case we're looking at a Universal Lighting Technologies LED driver, and you can read all the specifications. You can get dimensional information and other information directly here. Options, we went over those briefly. The OO option is no visor. The OP is for natatorium or pool or damp use. That comes with a sealed door frame, and then the 2 different visor options. This is showing the 433 with no visor, with the straight visor, and the flared visor. Color temperatures are available in 2700 through 4000 in 80 CRI, but we also offer the 4000K in 70+ CRI. We can also do other color temperatures such as 5,000 is available, 5,700 is available, but they are limited, or they're subject to a minimum purchase that we have that we would have to do. So the quantity would, it's a little bit of quantity sensitive, but just contact us and we'll let you know. Destination requirement code, this is either for US or Canada. All the fixtures are CSA certified to all the UL 1598 and as well as CSA for LED. The only difference really between the US and the Canadian version have to do with the labeling that goes to Canada. Some are in French. As far as dimming, we have the non-dimming, but we also have 0 to 10 ZX dimming, which dims to 5%, EL dimming, which goes all the way down to 0.1%, and then ED is also LDLA dimming down to 1%, but it's for dolly controls. The VPQ is the new pendant accessory for this luminaire. It's a rectangular cross-section stem, available in one-way or two-way. In lengths up to 120 inches. And there are options for pool, which actually do change some of the components to stainless steel. So you'd want to pay attention to that, as well as whether you want surface feed or if it's going to go over a recessed box. I'm going to pass it over to Zach, and he's going to go over some of the features shown on the website.
Now, most of these materials are already loaded. If you go on the website immediately, you might find between the 4 sizes, there may be some items that are still to come, but the majority of the information has been loaded. If you do come across an item you're looking for and you can't find it, feel free to reach out to us, though, because the PDFs and such are all available, and we could get those to you. In the meantime, if you find there is a cut sheet or something that isn't yet posted. If you click the main products button, you get 2 primary choices on our website. Find a product, which takes you to an area that's like a photo gallery where you can filter down choices, or at the upper right, you'll see Quick Finder. And knowing the style numbers now for this series, that would be your quickest way to get to all the technical information. So in this example, we're using the largest S434 style code, and that brings up then at the right all of your available choices. Probably the most frequently used would be the data sheet, which would take you to that black and white cut sheet that Paul already illustrated. In addition to that, the product fact sheets is a sort of catch-all bucket with several items in it. One of those is the color cell sheet. So if you need to present that to one of your design clients, that is available. The scale performance table that Paul already mentioned is accessible from the cut sheet through that live link. However, if somebody was to end up in this area of the site first, they can also get to the table from this product fact sheet area. The artwork of the solid state label or the lighting facts labels are available if somebody wants to see that in more detail. And in addition, we've been supporting IES's push to get people to try out TM30. We've probably been in all of our new product releases and actually going backward to existing products, probably for close to a year and a half. We've had this information available on our website. If you click that, you'll have access to zip files that are broken up by the primary color, temperature, and CRI selections. And that then brings you to a 7-page report. The 7-page report's really 2 reports. The IES spreadsheet that takes the color information and kicks out these summaries is available in 2 formats. We put them both together as a way of capturing all the information, albeit with some redundancy in the presentation. Here on the first page, what you're seeing in the upper left is the spectral radiance information for the tested LED. Behind it in the sort of black or gray line, you're seeing the reference test source for 3000K that this would be compared to. Below that, you have 2 bar charts. The upper one is the fidelity index for each of 16 color categories. Although there are 16 color families illustrated, TM30 actually uses 99 color samples, but in this particular bar chart, you're seeing that boiled down to 16 groupings. And much like the traditional CRI, although this ranking system behaves a little bit differently, it's trying to show on a scale of 100 how various colors, how faithfully various colors are being rendered. Below that is a gamut index, and that bar chart is trying to say that if you see a color or a bar creep above the horizontal datum line, it is being somewhat oversaturated. And in contrast, if you see any color bar creep downward from that horizontal axis, it's trying to tell you that those colors are being somewhat undersaturated. The circular diagrams to the right are another way of depicting that issue of color saturation. Wherever you see the color diagram creep inside of the circular boundary, that's an indication that those colors that are being represented are being somewhat undersaturated. And when you see colors like these blues creeping outside, those are being somewhat oversaturated. You see that some of that same information repeated here, but in addition, this page does add the XY color coordinates, and it also adds the traditional CIE-CRI index. And out of all the presentations we've done for new products recently, I think this is the first time by sheer coincidence, the traditional CRI value has been the same numeric outcome as this new fidelity metric through TM30. So in most previous presentations, there's been some difference in that. Off to the right here, this is kind of an odd diagram, but what it's trying to say is on both of these new indices, the gamut and fidelity, here's this test source, the 3000K LED being tested here, and all these other bullets are other sources that have been tested through IES TM30, and they have sort of built a library of various sources that you could do comparisons with. Moving on to the third page, you see the CIE color space and the black body curve represented. In the upper summary, you now get the addition of an R9 value. And in addition, there's a fidelity index for skin tones. There are 3 colors meant to represent a broader array of skin tones. And if someone is in an application where they're very concerned about how faithfully complexions would be rendered, that gives you yet another metric for trying to evaluate those considerations. This page has some information you've seen before. The upper left-hand diagram is just saying for each of the 99 colors, how did this tested source compare with the 3000 Kelvin reference source? So the red dots are representing each of the 99 color swatches that were tested and how that fell using this particular tested source, and the black dots are a 3000K reference source. This is a nice graphic chart that tries to show all 99 of the color swatches that are part of TM30, and furthermore, it takes each cell and splits it in half, and the left side of each cell is trying to show you how that color would be rendered by the 3000K test source, or reference source in this case, and the tested 3000K source is shown on the right. And you sort of see that here, gray tone, it's saying reference source on the left, tested source on the right. This bar chart, or both of these bar charts you've seen before, but this is the sort of representation of the fidelity metric across all 99 tested colors. So if you want to run the entire range of colors that were tested, this kind of gives you a good graphic indication of how faithfully each of those were represented. There is a comparison to conventional sources reference in a PDF form. Toward the end of the presentation, I'm going to discuss a few applications, considerations, and when I do, I'll dive into one of these tables in a little more detail. But fundamentally, they're there when you're trying to cross over either existing jobs or just in your own mind, if it's something where you're picturing like a house of worship done with a halogen or a large public space with metal halide, where should you turn in this new series? There's a PDF available, the full photometric test. It's labeled, and the call out is an ITL file. Ironically, in this case, UL did the photometric testing, and Paul will step through that report in more detail in just a second. The IES files are available, and multiple scaled reports have been prepared for each product. So whether you go to the 431, 432, 3, or 4, you can go through, pick the color temperature and CRI that you're interested in, as well as pick whether it's a visorless lensless, a visor and no lens, or a visor with the cover lens for a damper pool application, and save yourself the chore of having to apply multiplication factors to get from one test report to the condition you actually want in your design. There are Revit files available. These are face-based files, so whether you're a sub-consultant using the MEP package or an architect with the main file doing the architectural design, you can place these files appropriately in either package. And installation files, obviously not highlighted here, will be posted. Those will be available. So whether it's a designer wanting more information or a contractor or a distributor you're working with wanting that as part of a submittal, those PDFs will be available shortly. Finally, the Configure It gives you the ability to make a customized cut sheet. The screen shot we're looking at here is the so-called generic view of our configurator. As agents, you would see something very similar to this, except with the pricing information also side by side. But this allows you to go through, pick your mounting, your paint finish, your voltage codes, and so on. Boil that down to your particular selection. There's a note section if there's additional information you need to tag to that cut sheet as it makes its round. And once you fill that information in and have made all your selections, at the left, you're able to select Cut Sheet, which will then generate a new PDF. The final prompt is, do you know the project name and type designation? If so, you can enter that. If not, you just move on to Generate Cut Sheet. And this is what you get. It's a slightly morphed version of the standard cut sheet. It will give you that project name and type along with a complete number that you've configured. Any notes that you did add will appear below the specifications. And then on the back side, once again, you'll get the completed catalog number along with the project name and fixture type. I'm going to turn it back to Paul, who's going to take you through some of the testing and performance information behind this new series.
Okay, so this is the overlay that we saw in the back of the cell sheet, and it's showing the 434, 3, 2, and 1 overlaid on top of each other, candle power curves, which come from the LM79 testing. It's an independent test lab that we, in this case, it was UL, that we sent the 434 to, and you can see the catalog number 434 with the straight visor and 4,000 Kelvin ADCRI option. There's a photograph of the luminaire itself, as well as some of the results for the integrating sphere, electrical characteristics, as well as some of the in situ measurements, which we'll get into in a second. The third page shows color quality. It shows the location on the XY chromaticity diagram. You'll have the total output for the fixture, the efficacy, the CRI, the R9. It also even shows the TM30 values for the fidelity and the gamut. On the next page, you have your candle power curve, and the last page gives you the tabulated candela values. Now that all has to do with the fixture itself. Now we get into the chip itself. We talked about LM80 data, which is the lumen maintenance of the chip itself, rather than life that we used to talk about with traditional sources. LEDs are going to diminish over time, so that is kind of the proxy or what we use instead of life. In this case, we're looking at the flip chip white. It's a Lumiled's Luxion product. This is driven at 700 milliamps in this test, and you have 9,000 hours of actual data, and it was tested in 105 degrees C ambient. And you can see the values as they're projected stay very constant over the time. Typically, a manufacturer will test to about 10,000 hours, and after that, it gets too costly, and they're probably onto their next chip anyway. So you rarely see tests that go beyond 10,000 hours. In this case, it's 9,000, and that information is used inside the TM21 calculator, which I'll show in a second. The ISTMT is the in situ temperature measurement test, which is also done around the same time as the LM79. So what they will do is measure the temperature of the hottest LED in the fixture, as well as the driver itself. Now with this information, now that you have the LM80 data from the chip manufacturer and the ISTMT of the fixture itself, you can plug all this into the Energy Star TM21 calculator. It's a spreadsheet that you can download from the Energy Star website. Put in all the information, in this case, the data for the 85 degree test, as well as the 105 degree test. And you put in the information for, it was tested for 9,000 hours. This is the data for the 700 milliamp drive current testing at both 85C and 105C. So that's all the information for the LM80. The in situ inputs are coming from that test that I just showed you, The maximum LED temperature was 85, and now we were running at 500. So it's going to do an interpolation not only between the temperature but the drive current. And when you put in 70, this is asking, you're looking for what is L70, or what is the light output, or what is the number of hours to reach 70% of its original light output. And in this case, the calculated hours, if you were to run that line all the way till it reached 70%, is 319,000 hours. And then you'll see the reported hours, which is greater than 54,000. And this is because per TM21, you are not supposed to project or interpolate or extend beyond 6 times the actual test duration. So in this case, it was 9,000 hours. So we will use greater than 54,000 hours. So this shows you the newer version of the TM21. The first version used to show the calculated values. They have since taken that down and put up a new version where it just shows the reported hours. In this case, I've changed the L70 to 90. I want to see how many hours before it reaches 90% light output. And in this case, it was still greater than 54,000. The inverse of that is you can type in 50,000 hours and say, what is my lumen maintenance at 50,000? So they both show the same thing, but in 2 different ways. So this is saying at 50,000 hours, you're going to have greater than 91% of your original light output. And all of this is really to explain what this means on the catalog page. So underneath all the thumbnail diagrams, you'll see this L90 9K greater than 54,000 hours, which means L90, how many hours to reach 90% light output. 9K means you have 9,000 hours of actual data, and which is limiting it to 54,000 hours. I'm going to pass it back to Zach, and he's going to go through some applications.
Right, this is the last segment before we'll stop sharing the PowerPoint, and it's about 2:30 Eastern, so we're getting close to wrapping up here. This S43X series really is sort of, I don't want to say the final step, but it's sort of been the next step in the evolution that we started back in 2015. In February 2015, we announced the S104 series as our first so-called high-lumen. And at that time, the idea was to put it in a context of other sources you might have used from elliptipar to do spaces such as this. And when that product was unveiled, these were some of the images we used. The B&O Railroad Museum used 70-watt ceramic metal halide. So did the Utah State Capitol in the upper center. And the other 2 jobs, upper right, Booth Hill Elementary, and the Jackson, Wyoming Airport, using 150-watt ceramic metal halide. And it was really as part of the S104, slide freeze, there we go. We started doing these comparison charts. And for the 104, without getting into all the details, there were 3 sizes, 12-inch wide, 17-inch wide, and 24. And we were trying to compare the available delivered lumen packages and color temperatures with either a traditional halogen source or a metal halide. And in the case of the metal halide, we went on to actually give you both initial lumens and mean lumens at 40% of rated life, because frequently we would get into conversations where somebody said, well, I'm not trying to match the initial, I'm trying to match the mean or maintain lumens. Just so you know, these lumen values are delivered. What we basically did for these charts was back up to the old ITL reports and took off those reports the information, which was essentially lamp lumens times luminaire efficiency, to arrive at what got out, because it's that delivered lumens we're now talking about with all the LED luminaire testing. So what you're looking at here really is a chart that's comparing delivered lumens from a traditional fixture with an asymmetric distribution and a newer one. And the bottom line here was this family gave us tools that behave very much like a 70-watt, 150-watt, or 250-watt metal halide. And some of the early applications you see here. Here's a conference room, a scout shot from one of our agents locally who used back-to-back 12-inch units on shared pendant assemblies in this training facility. Here you see a house of worship where they're using uplights without visors to light not only the ceiling but the opposing painted wall. And a library shot taken mid-construction where they removed existing rectangular metal halide uplight boxes from these trusses and replace those with 17-inch S104 uplight. So while there were many applications like those where the 104 was a great fit, it couldn't take care of every space. And then a year later, last January, we moved into the S136 and 408, where we took the drivers out of the fixture head, put them in their own compartments, made some wider units, and through the use of a higher drive current, now that the drivers were remote from the fixture head or in their own compartment, and making the fixtures wider, we were able to ramp up the delivered lumen so we could handle some of these spaces that had in the past used, say, a 315-watt ceramic metal halide up through a 400-watt pulse start. And once again, we generated these tables to show that the 24-inch width was like a 210-watt elite lamp or 320 pulse start. The mid-size was like a 350 pulse start, and the widest 39-inch was like a 400-watt metal halide. And as you can imagine, that took care of another group of spaces, but not spaces such as these. What you see here is Akron University on the left. They use single 1,000-watt units in both their recreational pool pictured here as well as their competition pool. New Jersey Institute of Technology, that's their main competition gym, done with 1,000-watt units. We have the Auburn Tennis Center and Richmond Airport, which was a dual 400-watt design. So we knew that even with the 136 and 408, we had to get into that playing field. So once again, for each of the four sizes, we've generated these charts to compare to halogen sources, because we still get many inquiries from houses of worship with our halogen units wanting to replace them, as well as metal halide equivalents. In this case, the charts, because they're for each size, aren't broken up by how wide is the fixture. It's whether or not it has a lens or visor or not, whether it's visor and no lens, or visor with lens, which is the most challenging in terms of getting the light out through that secondary lens and dealing with the thermal management of now having that unit enclosed. And for each chart, you'll see sort of the same metal halide wattages presented against each of these options, whether it has a visor or a lens or not. And don't be surprised as you look at initial and mean for each of those three choices, you may be a bit higher or lower. And we just wanted you to see how each of those variations stacked up against the metal halide equivalent. So in this case, you're really looking at something that would replace a 210 through 320-watt metal halide or 1,000 halogen. Moving on to the double wide, that's a good choice when you're looking at either the 900-watt halogens, which were the GE lamp, like a 1,500-watt halogen output, or on the metal halide side, something between a single 315-watt, 350, or 400-watt metal halide. The 433 would be suitable for some applications where you might have considered a dual 400-watt, and the 434, the largest unit now, would be a good choice where you're looking at replacing or an alternative to a dual 400-watt or a single 1,000-watt. So we've been doing modeling of spaces with these IES files for a couple months now. If you have a project where you would like us to have a look, feel free to send any of that information to applications@thelightingquotient.com. Otherwise, as I mentioned earlier, the IES files are posted and available to you and your designers. If you do think of any questions after the presentation, feel free to email either Paul or myself. That would be p.ford@thelightingquotient or Zach, Z-A-C-H, @thelightingquotient. And that really ends the PowerPoint. I'm going to stop, if I can find the stop share.
Red one.
We're going to go back on full camera just so we can show you a few of the components up close.
Okay, so this is the light engine extrusion itself. And in this case, I just put more than the LED boards. But you can see the flip chip white or the chip scale package LEDs are very small. They have a very tight optical center, which is great for this design package. This is the looking at the extruded lens. This is actually in clear. This is one of the first prototypes that we had. It snaps right onto the light engine. And as you can see, it's centered on the LED itself. So in this case, you'd have two LED boards and two optics. Now we played around with some diffusion, and we got it just perfect so that we can avoid having to use that secondary holographic film that we've been using in the past. So having the diffusion incorporated directly into the optic has helped that a lot. In front of Zach, you'll see the 431, the 1 wide. It has 6 light engines or 6 LED boards going off. This is the one with 108 LEDs, and this will be similar to what the regional sales managers will have samples. And one side will actually have a clear polycarbonate end plate so you can see in. The other side will be finished. It will be a working sample so you can plug it in, and we'll probably have a potentiometer just so you could dim it to a lower level, probably on the side.
And that sample, which will be made to look, as Paul said, kind of like a cutaway with the one clear end panel to, you know, get across the point that this could be 1, 2, 3, or 4 modules wide. It will also have a piece of the straight visor, so it can be shown with or without that. But we're working out a method of packing that sort of separately, but in the same case, just to make it easier to manage the size and shape and weight. I checked the Q&A box. There were no questions for this particular one. Question that came up during some of the earlier presentations. One was the sample. So initially, those will be available through our regional sales managers to do calls with you. We fully anticipate that as projects come along, there will be those requests saying, hey, I need 1 or 2 units shipped to such and such to do a mock-up for my client. So certainly as those make their way out and come back, we're certainly going to make a stable of fixtures out of those that we can then respond more quickly the next time somebody's faced with a mock-up. One other question that came up was the non-dim codes. The main reason we've maintained that, although quite frankly right now a non-dim unit would be the ZX driver. We continue to look at available drivers, and there have been some interesting things brought to us in terms of non-dim drivers that might offer a really nice cost point. And if those become available from vendors that we're comfortable with, we may want to work those into the mix. So that's why we've continued to maintain a separate code, just that if those things become available to us, we'll already have the catalog logic in place. So with that, we thank you for viewing the presentation this afternoon. As I said before, any questions, feel free to reach out to Paul or myself. Thank you.
Thank you.